Welcome to Knox Talks, the AI-generated podcast exploring the groundbreaking ways technology shapes our built environment. Today, we're diving into battery-free building sensors and why they matter if you run or maintain buildings. You've probably heard the pitch. Install smart sensors everywhere, get real-time data, and cut energy use. But then someone asks the awkward question, who's going to change all those batteries? In a building with thousands of sensors, that can mean battery work almost every week. The technology that was meant to make life easier becomes another ongoing job. Battery-free or energy harvesting sensors flip that story. Instead of relying on disposable batteries, they power themselves from the environment. They only need tiny amounts of energy so they can live off indoor light, motion, small temperature differences, or the electrical fields around cables. Once they're in, they can run for many years with almost no attention from your team. Indoor solar uses small cells that run on ordinary office lighting and can power temperature, humidity, or CO2 sensors, even in internal rooms. Motion means devices like wireless light switches with no battery. When you press them, the mechanical movement creates a burst of energy that powers a short wireless message. Temperature differences let a sensor on a hot pipe in a cooler room turn that gap into power using a tiny generator. Electrical current lets some devices clamp around a power cable and harvest energy from the magnetic field so they can monitor the circuit and power themselves from the same line. These sensors still need to talk to your building management system. To keep power use tiny, they use ultra-low energy wireless standards. One example is the in-ocean protocol, designed so a single button press or a few seconds of indoor light is enough to send a message gateways, then translate that into BACnet, Modbus, or whatever your existing BMS is already using. Now let's talk money and risk, because that's what usually decides whether a project happens. Battery-powered sensors are cheaper at the start, but they come with a long tail of batteries, labor, access gear, and recycling. You also risk gaps in your data when a sensor dies quietly, or readings drift as batteries get low. Energy harvesting sensors usually cost a bit more per point up front, but once they are installed, the ongoing cost is tiny. There are no batteries to buy or dispose of, and far fewer callouts. When you add it up over a decade, total cost can drop by around half compared with battery-powered devices, especially at scale. What about wired sensors? They avoid batteries, but in most retrofits, they are the most expensive option. Pulling new cable through a finished building means opening ceilings and walls and working around tenants. For many projects, the wiring cost is what kills the business case. Does this actually work in the real world? Take the retrofit of the Empire State Building. Engineers deployed a large wireless sensor network across more than 100 floors, many of the devices powered by indoor light. The project delivered big energy savings and carbon reductions without drilling through historic stone or doing disruptive fit-outs for cabling. It proved that even very old buildings can support dense sensing if you remove batteries and wiring from the equation. Three big forces are now pushing adoption. First, regulation. New building codes and carbon rules in many regions are pushing owners to monitor and cut energy use. Second, technology energy harvesting hardware has matured. There are now many product variants covering everything from room sensors to plant monitoring. Third, market pressure. The smart building market is growing fast, especially in retrofits. Owners who move early can show better performance and stay ahead of the next round of compliance rules. So what can you do next? On your next project or upgrade, ask one simple question: where can we avoid batteries and new wiring? Start with obvious targets like room controllers, thermostats, window and door contacts, occupancy sensors, and condition monitoring on key plant. Then pick one small pilot, a single floor, a key tenant, or one plant room. Work with your controls contractor or systems integrator to pick energy harvesting options that integrate cleanly with your existing BMS. Track a few basic numbers: energy use before and after, sensor-related callouts, and the time your team spends dealing with batteries and access. After 12 to 18 months, you should have a clear local business case that you can repeat on other sites. Battery-free sensors are no longer science fiction. They are off-the-shelf tools that let you scale sensing without scaling battery headaches. If you care about comfort, compliance, and operating cost, this is a quiet shift you do not want to ignore. And next time someone talks about adding a few thousand new sensors, you'll know exactly what to ask. Great. And what's the plan for all the batteries?
Futuristic lights glow.